Welcome to Lesson 32, Variables and Evaluation. Our learning objectives today are to define variable, substitute values into expressions, and evaluate expressions correctly. So what is a variable? Well, a variable is simply a letter that represents a number, and the value of it can change, which is why it's called a variable, because it could vary. So some examples are x, y, or n, or any letter. And you'll start seeing these a lot more throughout pre-algebra and as you get into algebra. An algebraic expression is an expression that contains numbers, variables, and operations. So here are some examples. So you might have x plus 4. This just means a number plus 4. Sometimes you can see two variables next to each other. And when you see that, that means that you're multiplying these two numbers. So if m equals 3 and n equals 2, that doesn't make mn 32. It makes that 3 times 2. And sometimes you can also see numbers next to variables. And again, this means multiply. When they're right next to each other, you're multiplying those values. So this is 2 times y minus 7. So when we say evaluate an expression, it means to find the value of. So you'll be given the value of your variables, and what you want to do is replace the variable with the given number and then simplify your expression. And that is what we call evaluation of an expression. So if we have x plus 3 and x equals 5, to evaluate this, we just plug in 5 for x and you get 5 plus 3, which equals 8. So here's another example. Evaluate 3x plus 5. So again, when you see that x, and that does not mean times, that means a variable x. And in this case, x equals 4. So what we're going to do is just plug 4 in for x and multiply, and then add 5. And when we're substituting these values in, there's a couple ways that you can do the notation. So you can put parentheses around where your variable was, or you could use the little dot in between the numbers. So if you see the dot, it's 3 times 4. And I generally wouldn't recommend we put an x for times there anymore, because with having variables as x, this could get a little bit confusing putting a time symbol in there. So you'd want to stick with the little dot or parentheses to indicate multiplication. So we have 3 times 4, which is 12, and add 5 to equal 17. Now here's another example. So a times c plus 6 times a, if a equals 8/9 and c equals 1/4. So I'm going to go ahead and put in these values. A is 8/9, and we're multiplying by c, which is 1/4. And then we're going to add 6a, which is 8/9. So it doesn't mean 6 and 8/9. It means 6 times 8/9. Okay, so now we have our variables substituted with numbers. And I'm going to do some cancellation here before I simplify. So I can factor out a 4 from both of these, and that would make that 1, and this is 2. So I'm left with 2 times 1, which is 2, over 9 times 1. And then we're adding, and I can do some cancellation here too, because I could put this 6 over 1, that's 6 over 1. And I could factor out a 3 from the 6 and 9. So we'll change that 9 to 3. We'll change our 6 to a 2. So now I have 2 times 8, which is 16, and 1 times 3, which is 3. And now we have addition of fractions, which from a couple lessons ago, we learned in order to add fractions, we need common denominators. So I need to find the least common denominator, and that would be 9 in this case. So I'm going to be left with 2 ninths. Keep this as 2 ninths. And then I want to multiply this by 3 over 3 to get that denominator to be the same. So 16 times 3 is 48. 3 times 3 is 9. Now we have 2 ninths plus 48 ninths, which equals 50 ninths. And we want to simplify, so put this as a mixed number. 9 goes into 50 5 times. 5 times 9 is 45. And that means we have a remainder of 5. So 5 and 5 ninths is our final answer. So some common mistakes when we're evaluating expressions is ignoring the order of operations. We just went over order of operations in the last lesson. So remember, keep those orders: multiplication first from left to right, and addition and subtraction from left to right. And then changing the variable incorrectly. So understand the notation. So like in that last example, how we had 6a, just remember that that wouldn't be 6 plus 8 ninths. It wouldn't be 6 and 8 ninths. It's 6 times 8 ninths. So just remember the notation of when you see variables next to each other or next to a number. And here are your practice problems. So go ahead and pause the video or work on these on your own, and then press play when you're ready to check your answers. Okay, first one. X times y plus y times x. So we're going to do our multiplication first and then our addition. And this is when x equals 2 and y equals 4. So I won't write all this out, but we could just say 2 times 4 is 8, and plus 4 times 2, which is also 8, so 16. All right, m times p times x plus m times x. If x equals 3, p equals 4, and m equals 6. So go ahead and you can substitute all these numbers in. 6 times 4 times 3 plus 6 times 3. So 6 times 4 is 24 times 3 is what, 72? Plus 6 times 3, which is 18. So 72 plus 18, that leaves us with 90. All right, so your assignment is to do problem set 32 and go ahead and read lesson 33 in your textbook. Have a great day.